I am Alex, and I'm going to be talking about the Windbelt and power module portion of the commuter tracking sensor network. So what we have here is the Windbelt fixture, and it's connected to a whole lot of electronics. Particularly, we have a Texas Instruments boost converter, which serves to trickle charge a battery while being able to provide current to a embedded camera and a XB radio. And so what I'm going to show you, I'll basically demonstrate the cold start of the boost converter to show that wind energy can provide enough voltage and current to be able to bring the boost converter to operating levels. And then I'll be connecting the load in the circuit to show that it can provide enough power to the secondary power stage and our embedded camera module in particular. So first off, what I'm going to do is connect our battery source. So this is connected directly to the boost converter. What that's going to do is, since we don't have cold start enabled, the boost converter will still show that it's getting levels that are lower than 4.2 volts at the output. So what we're going to do is power on the boost converter now by applying a small amount of wind. Okay, and you can tell that the boost converter is on now because we are providing about 800 millivolts of input, and we have about 4 volts at the battery pin and a little bit more than that at the load pin. So we can actually just power this down because now we've cold started the boost converter, and the battery can take care of the rest. We don't need any more voltage to turn on the battery management system. So now what we can do is we should be able to, we already have these power modules connected for the secondary stage. This is basically a secondary boost converter, EVM, that provides 5 volts for us at the output. That's already connected and powered on. And then this is a secondary stage buck converter that's providing us with 3.3 volts. That's going to be used to power our XB. And both of those are connected and running. So if we connect this, we should be able to see that it's working. All right, get your status LED. And then we did, and then our 3.3 volts. You could basically just do a quick voltage test here. We have all the XBs in use right now for our network test. And I get help. Well, you guys? Oh, actually, I think I might be able to swing it. Yep. We got. Nice.
It's
About 3.3
yeah,
volts.
3.3. It's pretty solid.
Fluctuating?
No, it's solid.
Good.
Great.
All right. So, and then basically the next step in the whole prototyping process, this is a bit of a jump because we jumped right to the PCB portion of it. There were a lot of steps along the process, like we had to start with a basic transient analysis to be able to make sure that we were providing the correct amount of voltage at the output. That was all done through SPICE with library files that were provided by Texas Instruments. So we just basically ran a simple transient analysis, got our simulation results, and that verified that we could provide enough voltage to our peripherals. The next step in the process was actually breaking it out into a breadboardable prototype, and that involved purchase of a QFN to dual inline package converter. So we found one of those custom PCBs available, and used the reflow soldering techniques, put that together. Broke it out on a breadboard with all of the resistor, capacitor, inductor values that were necessary to achieve the voltages that we wanted. And then verified that all of our voltage values were correct right on the breadboard. Next step after that involved actually creating a custom PCB, so we didn't have, simply due to the fact that Texas Instruments doesn't provide a evaluation module that has the voltage values that we needed for our specific application. So that's what we did using Eagle. Basically came up with the schematic and layout design, and then sent away to OSH Park to have them fabricate it, and we have the completed product, which you saw functioning. Then we used the surface mount technology facilities on campus to be able to actually solder all of the components onto this board. And then the last bit was testing it, which luckily it just happened to work out on the first try. So, which isn't always the case. But yeah, that's pretty much the power module.